Meet Optimus, the humanoid robot that has captured the world's attention. Elon Musk claims it could eventually be worth more than every Tesla vehicle combined. But beneath the flashy stage demos and viral clips, is this machine truly as intelligent as it appears? Let us look past the hype. We are peeling back the layers of the marketing to examine what is really happening behind the scenes of this ambitious development project. Optimus is designed to mirror human proportions, standing about 5 feet 8 inches tall. It weighs roughly 125 pounds, similar to a person. Its primary purpose is to take over tasks that humans find dull, repetitive, or dangerous. It is built to be a tireless worker in industrial environments. The robot is intended to begin its career inside Tesla's own manufacturing facilities, handling the heavy lifting and monotonous assembly line duties. What makes this project unique is the manufacturing approach. Tesla is building almost every component in-house, rather than relying on external suppliers. By applying the same production philosophy used for their electric cars, they hope to achieve a level of vertical integration never seen in robotics. To understand how it works, imagine a human body rebuilt with machines. It relies on a sophisticated internal architecture to function. Instead of biological muscles, the robot utilizes 28 motorized joints. These actuators allow for a wide range of motion across the entire frame. These joints mimic the complex mechanics of human elbows, knees, and fingers, enabling the robot to bend, grip, and maintain its balance. It is a highly complex mechanical system designed to replicate the fluidity of human movement, which is essential for working in human-centric spaces. Powering this entire system is a high-capacity battery pack housed directly in the chest cavity, keeping the center of gravity stable. This battery technology is derived from Tesla's automotive division, providing enough energy to sustain the robot through a standard workday. The brain of the machine is equally impressive. It utilizes the same powerful computer chip found in Tesla's advanced self-driving vehicle systems. This computing power is essential for processing the massive amount of data required to navigate the physical world without human intervention. Integrated into the head are several cameras that function much like human eyes, capturing a constant stream of visual information. This visual system allows the robot to perceive its surroundings in real time, identifying objects and obstacles as it moves through a room. Unlike older, rigid industrial robots that follow a fixed, pre-programmed script, Optimus is designed to be far more adaptable. The core of its learning process is observational. Engineers record videos of real people performing specific tasks, such as folding laundry. The robot's computer studies this footage, breaking down the human movements into actionable steps that it can then attempt to replicate. It learns by watching, much like you might pick up a new dance move by observing someone else perform it first. This imitation-based learning allows for a much more flexible approach to complex physical labor than traditional static programming methods. The onboard computer processes this visual data in real time, making thousands of micro-adjustments to its joints every single second. This rapid feedback loop helps the robot react to its environment on the fly, allowing it to correct errors without needing a human to reset it. However, we must balance this excitement with a reality check. As of 2026, the robot still moves with a noticeable lack of human-like grace. It remains slower and less fluid than a typical human performing the same tasks, highlighting the gap between current tech and true dexterity. Furthermore, some of the most impressive demonstration videos have relied on hidden human operators to control the robot remotely. This remote control technique is a common practice in early robotics development, used to showcase potential before the software is fully autonomous. It is important to distinguish between what the robot can do with human help and what it can achieve entirely on its own. Mass production remains the most significant hurdle. Building a single polished prototype for a stage demo is vastly different from manufacturing thousands. Scaling up production requires solving complex supply chain issues and ensuring consistent quality across every single unit that rolls off the line. The technology is genuinely impressive, but it is not yet the flawless, seamless machine that we see in the curated highlight reels. It is still a work in progress, with clear limitations that the engineering team is working hard to overcome in the coming years. Musk has a much bigger vision than just keeping these robots on factory floors. He sees a future where they are part of our daily lives. He has spoken about Optimus eventually helping around the house, assisting elderly individuals with mobility, or managing chores. There is also potential for these robots to take on dangerous jobs, such as working in mines or handling hazardous materials in disaster zones. If Tesla can achieve the same scale and cost efficiency as its car production, the price point could drop significantly over time. This would make the technology accessible to a much broader market, potentially changing how we approach labor and domestic chores. The goal is to drive down costs until a robot is an affordable tool for businesses, and eventually, perhaps, for private households. This shift could be as transformative as the introduction of the assembly line was over a century ago in the manufacturing sector. It represents a major leap in how machines interact with our physical world, moving from static tools to dynamic, mobile assistants. We are witnessing the early stages of a transition that could redefine the relationship between humans and automated labor. The potential for increased productivity is immense, provided the technology can overcome its current speed and reliability limitations. Engineers are constantly refining the software, pushing the robot to learn faster and move with more precision than ever before. Every iteration brings the machine closer to the level of autonomy required for widespread, practical application in the real world. It is a race against time and technical complexity, with many other companies also vying to create the first truly useful humanoid. Tesla's advantage lies in its massive data collection from its fleet of cars, which helps train the AI models that power the robot. This data-driven approach gives the company a unique edge in teaching the robot how to navigate and interact with the world. As the AI improves, we can expect to see the robot performing more complex tasks with less human supervision in the near future. So, is Optimus the future of work, or is it just an expensive experiment that is still struggling to find its footing? The truth likely lies somewhere in the middle. It is a bold attempt to solve one of the hardest problems in engineering. Either way, robots have taken a significant step toward becoming a part of our everyday lives in ways we once thought impossible. The progress being made is undeniable, even if the timeline for mass adoption remains uncertain and prone to delays. We are watching history unfold as these machines move from the laboratory into the real world, one step at a time. The question is no longer if a robot can perform these tasks, but how soon it can do them reliably and affordably. As the technology matures, we will likely see these machines appearing in more diverse settings, from warehouses to hospitals. Would you feel comfortable having a robot like this in your home, helping with your daily chores or assisting your family? Share your thoughts in the comments below and let us know what you think about the future of humanoid robotics. Thank you for watching this deep dive into the technology behind Optimus and its potential impact on our collective future.